All right, now that we know the different parts of the atom with the proton, the neutron, the electron, and a little bit about the scientists that discovered those particles, we're going to look at how atoms are different, because Dalton originally thought that all atoms of the same element were always the same, but they aren't. So we're going to look at here exactly how they were different, and we owe a lot of that to Henry Moseley. He was an English scientist, and he discovered that atoms of each element contain a unique positive charge in their nuclei. And the number of protons of an atom identified that atom as one of a particular element. And that number of protons we call the atomic number. So he then organized the periodic table from left to right and top to bottom by increasing atomic number. And we'll talk more about the periodic table and how that came into play a little later on in another chapter. But for right now, just know that Henry Moseley discovered that each atom has its own unique positive charge that we call the atomic number. Now remember that all atoms are neutral, so your number of protons will equal the number of electrons. If you take a look at the picture, this is a very typical square for a periodic table. The top there has a chemical name, and then we have the atomic number, which I just talked about, which is your number of protons. And then you have the chemical symbol, and you have the average atomic mass. We'll look later at the average atomic mass. Okay, so now we're going to use our periodic table to complete this table that deals with element symbols, their atomic number, their number of protons, and their number of electrons. Let's remember that for any element, your atomic number is the same thing as the number of protons, and if the element is neutral, your protons should equal your electrons. So for lead, take a look and look up lead on the periodic table. And what you should find is that it's down there in the lower right-hand corner. It is number 82. So if I have 82, so if 82 is the atomic number, that means that I have 82 protons and 82 electrons. You can also go backwards and say, all right, if I have 8 protons, that means my atomic number is going to be 8, which means that my element is going to be O, which is oxygen, and my number of electrons is also going to be 8. Same type of thing. If I have 30 electrons, I'm going to have 30 protons, which means my atomic number is 30, which means my element is Zn, or zinc. Let's look at a couple more. For boron, how many protons and electrons are in each of the following atoms? We find boron on the periodic table, and we notice that it is atomic number 5. Its symbol is a B. So if the atomic number is 5, that means my protons are 5, and my electrons are 5. If we take a look and find radon, radon is Rn. Its atomic number is number 86, which means I have 86 protons and 86 electrons. And then finally platinum. Platinum symbol is Pt. It has an atomic number of 78, which means that its protons are 78 and its electrons are 78. All right, as I mentioned earlier about Dalton, his theory was wrong about atoms being indivisible, and it was also wrong about that all atoms of a particular element are identical. While it is true that all atoms of a particular element have the same number of protons and electrons, your number of neutrons in a nuclei may differ. Remember, neutrons are the ones that do not have any charge, but are right there in the nucleus with the proton. Also got an example of potassium atoms. There are 3 different types of potassium atoms. All 3 types have to contain 19 protons and 19 electrons. Otherwise, they wouldn't be potassium. They didn't have the 19 protons. However, one potassium atom has 20 neutrons, another one has 21, and another has 22. Atoms such as the potassium, with the same number of protons but different number of neutrons, are called isotopes. In nature, most elements are found as a mixture of isotopes. Usually no matter where a sample of an element is, the relative abundance of each isotope is constant. For example, there is going to be the same amount of each isotope in different samples of matter. For example, a banana, which has a lot of potassium, is 93.25% potassium atoms with 20 neutrons. 6.73% is a potassium atom that has 22 neutrons. And a very small number of 0.0117% has 21 neutrons. The percent composition of potassium isotopes will still be the same. So those percentages that I just read off will always be the same whether I have 6 bananas or 1 banana. So we call that our percent composition for an element. It is made up of the same number of isotopes in each thing. Isotopes that contain more neutrons will have a greater mass, but they do actually have the same chemical behavior as any other isotope. To make it easier to identify these different isotopes, chemists add a number after the element's name, and we call that the mass number, where your mass number is the number of protons plus the number of neutrons in a nucleus. So for example, if I have my potassium isotope that has 19 protons and 20 neutrons, my mass number is 39. And we call it potassium 39. When we say potassium 39, that is what we call word notation. If you want to look at a symbol notation, that is like the picture we have here, where the mass number is on top and the atomic number is on the bottom. A lot of times you will not see the atomic number written because it is understood when you have the chemical symbol sitting right next to it. Because all silvers are 47 on the bottom. So a lot of times you'll just see the 107 or the 109 up in the upper left-hand corner. That is again called symbol notation. Alright, so now we're going to take a look at these isotopes and writing them in the correct notation, both word notation and symbol notation. So here we go. A chemistry laboratory is analyzed the composition of isotopes of several elements. Determine the number of protons, electrons, and neutrons in the isotope. Name the isotope and give its symbol. We're going to name the isotope in both symbol and word notation. So let's start off with our first element. So let's take neon, right, which the atomic number is 10. And that means that I have that number of protons. So neon has 10 protons. Since it's a neutral atom, I also have 10 electrons. Now the neutron part. Remember that your mass number is your protons plus your neutrons. So if I want to figure out how many neutrons I have, I take the 22 and subtract the protons. So 22 minus 10 is going to be 12. So I have 12 neutrons. So when we write it in symbol and word notation, the word notation, we just put neon and then the mass number. When I go to write it in symbol notation, put the mass number on top and the symbol for neon, which is Ne. You can also put the 10 at the bottom. I rarely do though because I know when I see neon that the atomic number is 10. So now let's take a look at the next one, which is calcium. Okay, and calcium has an atomic number of 20, which means that I have 20 protons. Since it's a neutral atom again, that means that I have 20 electrons. My mass number is 46, so I want the number of neutrons themselves. I take 46 minus 20, it's going to be 26, so I have 26 neutrons. Again, when you write them out in word notation, I'd have calcium 46, and then you do 46Ca. Go ahead and try the last two. So pause the video, and then when you get your last two done, go ahead and come back and check. Okay, these are what you should get for your last two then. Oxygen 17 and iron 57 with 9 neutrons in oxygen and 31 neutrons in iron.